All right, my name is Mark Webb from MKW Ventures Consulting, and I'll be talking about 3D Crosspoint Optane media memory markets, bits, revenue, costs, and application primarily for data center and what we can do with these new architectures. We'll talk about 3D Crosspoint Optane history and background, 3D Crosspoint products, models for the technology Gen 1, Gen 2, estimated performance metrics in 2020, bits and revenue. We'll look at cost versus other memory technologies, and then finally give a summary of where we are. So what is 3D Crosspoint? And again, I've done lots of details on this before. Micron and technology that was announced in July 2015. As a disclaimer, Intel doesn't have 3D Crosspoint anymore. It's called Intel Optane Memory Media. So that's what they refer to it internally. It is a phase change memory technology in a crosspoint array with about a 4F² cell, which is then stacked. The lithography is about 20 nanometer lithography. The key takeaway for this is it's faster than NAND, slower than DRAM, cheaper than DRAM, more expensive than NAND. So it's not replacing either technology, but it's something that fits in between with certain aspects. What's new this year is the second generation includes 4 decks, I think they're called by Intel, or layers. So it's the first generation was 2 layers. So if we look at new memory technologies compared, and I'm just looking at a couple of them here, the key takeaway that affects 3D Crosspoint is we have all the technologies that are out there, but the key is 3D Crosspoint is HVM ready. It's been running in production, multiple applications, so we have a lot of volume on it. Everything else is kind of in between on latency, density, and cost. But overall, the big aspect is compared to other memories is it's HVM running, it's running in volume. So if you look at a simple architecture overview, this is a slight update to a slide I've showed before. One of the things is 3D Crosspoint is not 3 years in the making, it's not 5 years in the making, it's really not even 10, 15 years in the making. It's been around coming for 20 years. And if you look at the history, before it went into stealth mode and kind of disappeared, 9 years ago, Greg Atwood from Micron Technology published at FMS 2011, showed basically what the Crosspoint technology would look like. There's papers in 2001, 2005, and 2009 that were also published. Then you have, from the middle show here, you can see that this is a cartoon that Intel has. And then you see there's been speculation over the years on the technology. And the one big update was at Intel Architecture Day in 2020. They announced the second generation as being 4-deck. This is something we actually predicted 4 years ago, as saying it was going to be 4-deck technology. They showed it, and then this is from a foil that Intel presented at the Intel Architecture Day. So if we look at a product update for 2020, Intel Gen 1 products, they have the fastest SSD with the best SSD endurance, selling millions of units. So a big application of it is really in SSDs. The DIMMs were launched in April of 2019. The sales have been growing steadily, still a relatively low attach rate, and probably lower than Intel would wish, but it is steadily growing. Right now, less than 5% of servers sold today have Optane DIMMs in them. But that, again, that is still a significant amount of volume, and Intel expects it to grow. There's more Optane or 3D Crosspoint bits are sold annually than all other emerging memories combined. Intel Gen 2, and I'll talk about the star in a second, products are coming out. So the cell chip speed and endurance are not significantly changed on the Gen 2 chip. We expect the endurance targets to be about the same. We expect the speed to be about the same, even if it has 4 layers instead of 2. The DIMM speed is increased due to a controller change and the bus speed. Gen 2, which is Barlow Pass, or I refer to as Blue because it has the blue heat spreader on it, is available with the newest CPUs that Intel's announced. But again, the big in speed improvement is really from the bus speed, which is due to the controller in the bus. The SSD speed for Gen 2 products is greatly increased due to PCIe Gen 4 configuration and controller. So again, what we're seeing is, in my opinion, basically the same type of speed of memory and endurance, but the controllers have improved, and we'll talk about the implications of that. Micron products will ramp on Gen 2, but are still in development. So there's a product that Micron announced. It's really going to be more of a development vehicle, but we expect revenue from Micron, measurable revenue from Micron in the 2022 timeframe. Now, the definition I said might be complex. If a Gen 2 product doesn't have a Gen 2 chip, what would you call it at that point? And we're still speculating on that. Product forecast. So Optane and eventually Micron 3D Crosspoint SSDs will differentiate themselves more from fast NAND products in 2021. So if you want to get the fastest SSD today, you can get what they call fast NAND or low latency NAND SSDs. The difference is we think that the 3D Crosspoint SSDs will further pull away from this because the controller improvements that are made and the PCIe Gen 4 allows the chip and cell speed differentiation to shine through. Whereas when it was on Gen 3 with older controllers, it was kind of held back, if you will. The Optane DC persistent memory will grow steadily. Gen 1 and Gen 2 DIMMs will continue to sell and grow steadily. But in my opinion, the future persistent memory is not on the DRAM bus. The right answer for having multiple sources, growth, and easier development is a new bus, CXL, or it could be others as well. This will lead to an inflection point in the 2023 timeframe where we see adoption of persistent memory really take off. Technology update for 2020. We had Gen 1 chips for the first SSDs, DIMMs, and memory modules. That technology was a 128 gigabit device, 20 nanometer. It was about a 200 millimeter die size, 2-layer stack, and according to our estimates, the endurance grew to over 200,000 cycle capability. It started out much lower than that. We now have Gen 2 and upcoming Intel PCIe Gen 4 SSDs, which will be announced and released in late 2020. We predicted this before to be a 4-layer, 256 gigabit chip, similar cell and chip performance as previous technology, but again, higher density. And at the time, we were modeling 35% lower cost. Then what happened is Intel announced Barlow Pass. It's the Intel persistent memory module, or persistent memory, 2nd gen DIMMs. The shocking item was that there was no change in the DIMM density. Gen 1 was released at 128 gigabyte, 256 and 512, and the 2nd gen was released at exactly the same density. So the question is why? Well, after discussing with some people, the key issue is that customers want lower density products. They're just implementing it now, and if you compare it to some of the other NVDIMMs, which are much lower density, customers are not ready for 1 terabyte of memory. That's not a high volume decision or product that people want. One online publication stated that this product will actually be a Gen 1 chip in a Gen 2 module. Again, we haven't seen the teardowns on this. We're guesstimating something in between. My prediction is not quite Gen 2 chips are going to end up in some Gen 2 DIMMs, and we'll see the details soon when we get the teardowns on those devices. So I expect when those come out, we'll publish a note on it explaining exactly what's going on and how they're managing this. And the key reason why is because the higher density is not necessarily needed on DIMMs. 3D Crosspoint capacity and manufacturing. 3D Crosspoint is manufactured only at the IMFT facility. Actually, I should have changed the name on that. That is the Micron Utah facility, Micron in Lehi, Utah. Intel Micron have a 2020 supply agreement, which they agreed to earlier in the year to supply Intel's needs for the future. So they broke up the joint venture, but now they have a supply agreement going forward so Intel can get parts from the Lehi facility for the foreseeable future. Micron is still using minimal capacity and has minimal revenue other than Intel in 2020. As I mentioned before, the X100 SSD is more of a development vehicle for future products. That's fine. Everybody needs to start off and do the development, and we're expecting revenue from Micron in the 2022 timeframe. Looking at some financial records, estimates of volume shipped, the Lehigh factory is not a limiter in the near future for Intel's needs or anybody else's. No new capacity is needed. Last year, we forecast what the capacity of the factory is, saying that we had Gen 2 and Gen 1 capacity. We're updated that. We're thinking that it goes from 40 million gigabytes per month available Gen 1 at the end of 2020 and 25 gigabytes per month of Gen 2. And then that'll go to, in Q4 of next year, it'll go to 30 million gigabytes of Gen 1 and 55 million gigabytes of Gen 2 per month can be generated. Again, capacity is not shipments. We think Micron's underloading the factory, but this is the capacity. So it tells you whether or not we see an issue with being able to get capacity going forward, and right now we don't. 3D XPoint applications, you have the fastest NVMe SSDs available on benchmarks. I say probably because I'm sure people would argue about it, but I think they are. Optane memory for PCs, it's a cache for HDDs and speed storage. Millions of units have been sold. Intel announced some QLC NAND Optane combinations in 1M.2, cost-effective performance versus TLC SSDs. Then we have the DIMMs, Intel Optane DC persistent memory DIMMs. In memory mode, you have a large main memory cached in DRAM, but it's not persistent. And originally, some people speculated that this was going to be the main application. It might have started off that way, but the main application is the second one, which is so-called app direct mode. That's what we call true persistent memory. This is the main focus. And if Intel's going to make breakthroughs on architecture, and when we talk about what should be used in the data center, this is what you want to use it for. It can also act like an SSD on the DRAM bus, so you can use it for block modes, file modes, etc. Coming soon, you'll see Optane persistent memory on a new bus, CXL. That'll be coming out, probably being developed and sampled early on, and then over the next 2 to 3 years, you'll see that in production. Another question that came up is 3D XPoint now making money? The short answer is no. Operating margins are very negative. SSDs were the first product, and the sales were all in the Intel NSG group. A number of people did reasonable math that showed losses on XPoint of greater than $300 million per quarter. It was low volume, expensive development, difficult product. It's really not good for that. NSG losses dropped, but some of this is due to moving the focus, the expenses, and the bits to DCG, and also much better NAND prices on enterprise SSDs. Our model still shows a large negative margin impact to DCG. As persistent memory sales increase, you'll get more and more of that cost and margin impact will go to DCG. On the other hand, none of this matters because persistent memory is great for the data center and Intel architecture and differentiation, and I said from AMD, but actually from all competition. The margins on storage and memory is not the goal for Intel. It's really selling the platform and all the technologies around the data center. So the competition for 3D XPoint, competing PCM technologies. All companies have worked on PCM. Many showed information at recent conferences. We still expect XPoint PCM announcements from multiple companies like Hynix, Samsung, etc. MRAM is great for speed embedding, but can never compete on cost or density. Its competition really is SRAM, not really DRAM or NAND. Resistive RAM, XPoint resistive RAM technologies are the most direct comparison to 3D XPoint. Cell size, cost, speed, cycling, and applications are potentially similar. But the issue is at 2019 IEDM and a lack of, we saw a lot of issues presented that kind of questioned how fast we're going to be able to ramp resistive RAM. There were a number of new failure modes, and we weren't sure about how to fix them. And then there's a lack of new products. We haven't seen any new products on resistive RAM, especially a XPoint array. So we're really no closer to production than we were at FMS in 2019. Another competition is from fast NAND, so-called low latency NAND. NAND plus DRAM solutions from NAND and NVDIMM companies will compete in both DIMM and SSD formats and also on a new memory bus. So those are the competition that you should be tracking and making decisions on what to choose. Cost and price for 3D Crosspoint DIMMs. Key 3D Crosspoint feature is low cost compared to DRAM. This enables more total memory. Our estimates to cost were going from on Gen 1, 0.6x DRAM cost. In 2022, we think that will go to about 0.45x DRAM cost. And then the cost on Gen 2 will go to about 0.4 times the DRAM cost. The prices you see typically are a list are actually DRAM prices, or actually they're even higher if you look at channel prices. In the ASP, I gave the incredibly vague comment of it's less. The comment I make is after looking at some Intel financials, the ASP projection is very difficult. Intel is looking to drive growth and expense of margins. It's also expected that Intel is providing strong incentives for large customers to implement. This can also impact revenue projections. So we know that when Intel wants to implement new technology, they'll give strong financial incentives for people to implement it. And as a result, that can affect the price. And I would expect to see wide-ranging prices depending on whether it's sold in the channel or what Intel is contracting to some of its best customers. So if you look at 3D Crosspoint revenue, back in August 2019, I said the total revenue would go from 1.35 billion in 2020 to 3.6 billion in 2024. I broke it out by DIMMs and non-DIMMs. I updated it this month based on a number of data points, including some of the finances that came out from Intel's most recent earnings report. And the updated numbers in total are 1.1 billion in 2020, growing still to 3.6 billion in 2024. And one of the big changes, if you go through the details of this graph, of this chart, is the fact that up till 2022, I think there will be continued limited adoption. After 2022, when we move persistent memory to a CXL or other new bus, I think you're going to see a big jump in sales that come after that. And that'll be very enabling across the board. And that's going to be what's going to get us to the 2024 levels of revenue. So it's not, somebody had speculated, I think, $8 billion in 2024 a long time ago, but 3.6 billion is definitely something that Intel's planning for, and it's on track. This actually includes both Micron and Intel. Micron is expected to be minimal impact until 2022 plus. And one of the other questions that came up is, where did you get these numbers from? Some people were asking and saying, these are all basically sourced from raw data that I created based on the sales of Cascade and Cooper Lake, what their market share is, what their DIMM attach rate is, what the sale price is for that, and the average Optane density. We may get lucky, and with the breakout of the Hynix NAND sales, Intel may report out revenue numbers that allow us to have more insight into what their actual revenue is. So in summary, 3D Crosspoint ramp has been slower than we projected, but it has surpassed all of the new memory technologies and shipments. Rev 2 3D Crosspoint is shipping today. Teardowns are coming soon. Focus is on 3D Crosspoint DIMMs for persistent memory. Again, there are SSDs, but DIMMs are the focus. That's the breakthrough technology. DIMMs are shipping today. Bits are growing steadily since mid-2019. 3D Crosspoint SSD revenue is expected to grow in the future based on Intel and Micron shipments and new PCIe 4 products. DIMM revenue is growing steadily, and persistent memory revenue will take off at a faster rate with the launch of a new bus architecture in 2022. Total revenue is just over 1 billion in 2020, growing to 3.6 billion in 2024. And that's all I have. Thanks.